I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Okay, Jam, I'm excited about this topic. And I think you're not going to care about it at first, but then I think you will care about it.
Okay. Interesting.
Okay. So this episode was requested a long time ago by listener and friend of the show, Sam N.
Okay. He has been able to give us lots of good ideas.
Yes.
And lots of ideas that we haven't even done yet, too.
Yeah.
So
if you think you're asking too many questions, Sam is asking more. And he asks me them, and sometimes it takes me a long time to get around to doing them, but they're in my mind and on my list.
Okay.
So if you, like Sam, wonder a lot and you're worried about spamming us, don't.
Right.
We want your questions.
Yes, true that.
And Sam has a knack for asking questions that are answerable in that there's a lot of information about them and that they are interesting and exciting to me too. There's usually like a twist or turn.
Right.
So I think that helps too.
Okay.
So his question was, the ladies at my work talk a lot about Botox. What is it? So see, I think you wouldn't care initially because you don't care about reducing wrinkles. You like wrinkles other than sun damage.
Yes, that's very true. I've probably surprisingly strong opinions about something that most people, I don't know, probably wouldn't care what I think about it. But I have strong opinions about it. However, I know nothing at all about Botox other than just the, name dropping in shows and stuff like that.
Yeah. Well, I think you're about to get more strong feelings because I had no idea about this and I think it's really cool.
Okay. Interesting.
Okay. And this is a little lighter episode. Last week we were like kind of down in the weeds of the chemistry.
Yeah.
This one's a little lighter on the chemistry and more like a broad overview.
Okay. Cool.
Okay. So Botox is commonly known as a cosmetic procedure. It actually is a trademarked name and it helps reduce wrinkles. It's used therapeutically in medicine too, though. It's not just used for wrinkles.
Okay. Interesting. I did not know that.
I didn't know that. I think maybe deep down I knew that because I searched my messages for the word Botox and one of my friends told me they got a Botox shot to relieve pain. So I was like,
Interesting.
Yeah. So it's trademarked name for a purified substance. It's a protein actually known as botulinum toxin.
Botulinum toxin. That doesn't sound good.
No, it doesn't. But Botox comes from BO is the first of botulinum. And tox is the first three letters of toxin. So Botox, the trademark name, is actually sort of short for that.
It already just doesn't sound good. Toxin's not a good word for most of us. But botulinum, that reminds me of botulism.
Well, that would be correct.
Okay. So both those don't seem like good things to me.
No, they're not. So it's called a toxin because it literally is a toxin.
Oh, okay.
It's a toxic substance produced by it's actually by a range of types of this specific bacteria called Clostridium botulinum. So hopefully I said that right. Who knows if I did or not. There's a few different types of that bacteria, but they all produce a variety of this botulinum toxin, and they function primarily in the same way. So we're just going to generalize by saying this toxin or botulinum toxin. Okay, so this toxin that's used in Botox is the most poisonous substance known to man.
What?
Or maybe toxic is the most toxic known to man. I don't know the difference between those two, but in a 2005 Chemistry and Engineering News article, they said it was the most toxic substance known to man. And the Chemistry World podcast, they also write out articles, also said something similar.
What the heck?
And the reason it's so toxic is it's very, very, very potent at small amounts. And when I was listening to the Chemistry World podcast about this, and they said the scale on which you could die from this, my jaw literally dropped. I was in the kitchen listening to this podcast, and I went, and my mouth was hanging open when they said it.
Dang, wow.
So the toxin is so potent that now I need you to take this in.
Okay.
The amount that could kill you is on a nanogram scale.
Nanogram.
And a nanogram it's like, what does that even mean? Okay,
Yeah.
so a nanogram is a tenth of a millionth of a gram.
Wow.
Yes. So if you had a gram, and some resources say it's 2 nanograms and some say 30, so that's a little bit different, but sort of like 1 coffee bean is usually a gram. Like the amount of coffee Mason measures out for his cup is like 18 grams in the morning.
Yeah. Yeah.
And different substances have different volumes corresponding to their masses, different densities, but usually a gram is not taking up a huge amount unless it's like feathers or something,
Yeah.
something very light.
Yeah. I remember as a kid, always in school, they said a paperclip is a gram. Like that was like the kind of thing that is associated with it. And is obviously paperclips kind of vary, but like
Right.
most people have interact with them,
Right.
And I've always thought about that, even though I've never really weighed them.
Yeah.
It's just like, oh, okay, that is very small.
That is small.
Yeah.
So if you imagine a little pile of sugar, or I guess I imagined it as a white powder, I don't know why, and you broke that up into a million piles.
Okay.
That's a millionth of a gram.
Wow.
And then you take one of those piles and you divide it up further, depending on the scale, the 2 nanograms or 30, either into, 10 piles or 100 piles. Let's just say 10.
Yeah.
So you took your 1 millionth and then you divided that up further. And that's how much you'd need to take in to die.
Wow.
It's not a lot.
That is so scary.
I know.
What the heck? What are we doing messing around with this stuff?
Well, also, there's some good news about it, too, that you're not going to die like instantly.
Okay.
And I think, although I was not able to confirm, the worst thing is when it gets to your respiratory system. That's really how it kills you.
Okay.
So breathing it in, I think it would act a lot faster and be a lot more dangerous. And it does not naturally occur in an airborne toxin form. It typically occurs in food.
Got it.
So you're not super at risk.
Right. What if there was some substance that you're like, this is incredibly toxic. If you ingest this amount of it, you will 100% die in 100 years. It's like it had some sort of weird delayed effect with a certain. It's like, oh, well, I mean.
Well, I think it's acting quickly, but you just don't die right away.
Right. That'd be kind of a funny predicament. Be like, okay, wait, do I inject this stuff and know I'm going to die in 100 years? But aren't I probably already going to be dead?
You're probably going to. Yeah. Yeah, definitely.
Like it had some sort of very specific delayed effect.
Unless something happens between now and then to where they can extend human life.
Right. And then you've already made your bed.
Yeah. Like the Numenorians. They could, and then we've missed out.
Yep. Yeah, very true.
That was a deep cut reference to the new Lord of the Rings show.
Mm-hmm.
If you know about that race and their ages.
Yeah, that'd be crazy. Okay. Sorry.
So you're back in it.
It takes very, very little. And it has to be
very little.
Usually respiratory, that would be the most like fast way.
I think respiratory is the most potent.
Okay.
So if someone was like developing this for biowarfare, one of the sources I read said, this is insane, 1 gram, ground into an aerosolized powder and spread evenly could kill over 1 million people.
What the heck?
1 paperclip size.
Jeez.
Spread evenly. But obviously, logistically, that's hard to do.
Right.
And then another thing that I read, and also if you were the person developing that for biowarfare or whatever, like how could you keep yourself safe? Because if any little tiny bit of it is ever left in the air at all and it comes to you, that's it for you too.
Yeah.
You'd have to wear a respiratory mask for the rest of your life.
Yeah.
They also said, a different site said, which the math on this isn't exactly add up, but they said 50 grams could take out the entire population of the world.
Golly.
I know. I just can't wrap my mind around that. Like, truly, I can't. When they said nanograms, I was like, oh,
yeah.
Immediately, like, jaw on the floor.
That's so weird, dude. I just can't really comprehend it.
No, that's why I did the 1 million piles, because I had to think through what even does one 1/1,000,000th look like.
Yeah. That's crazy.
So pretty wild.
Yeah.
So it's not very much that you need. So that's why it's been classified as the most dangerous toxic to man.
Okay.
And the way it works is it paralyzes you. and causes what you've heard of as botulism.
Okay.
So when you said botulism, that's right. Botulinum toxin causes botulism. And it paralyzes you essentially by using chemistry.
Okay. So somebody taught this thing chemistry?
Yeah.
Are you kidding me? Dangerous toxin. And somebody thought, why not teach it chemistry? That is just so maddening.
It taught itself, I think.
Okay.
Hard to say. So it works by interrupting the chemical signals in your body. So there are proteins in your body that release chemicals, literally just whatever the specific thing it's supposed to send a message. That chemical can sort of send a message. It causes the things around it to do specific things that basically acts as a signal is what they call it.
Okay.
So one such chemical is called acetylcholine, and if it's released by this specific protein, it causes your muscles to contract. So if your brain says you need to lift your arm up over your head, or you need to, lift a weight or whatever, the brain will send that neurotransmitter. It will be released into the muscle, and they will then contract, obviously on a much quicker scale.
Right.
So, and I think a lot of this happens pretty automatically because there are other muscles that contract as well, like your lungs are contracting and your digestive system contracts. So there's other contractions happening that you don't specifically have to tell, but your brain is still doing it, which that's one of the things about neuroscience that's amazing.
Right. That things are happening that we don't have to voluntarily do.
Yeah.
And that they are hugely important for our survival.
Right. So your brain uses these chemicals really to keep things going. So that's why when people say things are chemical free or you want to avoid chemicals, don't listen to them unless they say dangerous chemicals, or, get some clarifying questions, because chemicals are everywhere.
And you probably do want some chemicals in there. For instance, soap. You actually want soap to be in there. If you're buying some soap, you want the soap to be there. Mm-hmm. And that stuff is chemicals.
I know. Yeah.
So you want some chemicals.
I know. That's one of my things on TikTok is I know what people mean. I like recipes that don't have a lot of extra stuff in them, but I can't get behind it when people say chemical. There's so many chemicals in this, and this other thing is natural, and it's like blueberry muffins. And I'm like, okay, yeah, but there are so many chemicals in those muffins.
Right.
Yeah. Anyway, okay, that was a little sidebar. Let's get back into it.
Okay, so back to things you can't eat that aren't blueberry flavored, and
you might be able to eat acetylcholine. I don't know what it's like, but you can't eat botulinum toxin without some serious side effects.
Right.
So acetylcholine is, this signal that your brain sends that basically tells your muscles to contract.
Okay.
And it's released from a protein. And it does so when, it's given all the right things to release it. That's a biochemist's job to tell us. I'm sure we have some cool biochemists who follow us that like to give me information after the fact. And then that's good stuff to share on a Q&R. So hopefully our biochemists will tell me how neurotransmitters, what happens to make them release. But that's a story for another day. For today's day, what happens is the botulinum toxin has two parts, and I think of it as a part that is sort of an invisibility cloak or a shroud of invisibility, and another part that does the damage. So one part is like sneaking us in, and the other part is getting the stuff done.
Okay.
Almost like they're on a secret mission.
Okay.
So the one part is a peptide. So if you remember all the way back in biology, proteins have peptides in them, and peptides are long strings of repeating units of amino acids.
Okay.
And amino acids are made up of carbon, hydrogen, oxygen, nitrogen as the sort of basic elemental building blocks.
Okay.
Okay. And we talked about once how proteins are basically just polymers inside your body.
Right.
And we got excited about that.
Yes.
So one part of this toxin is a peptide.
Okay.
And that peptide recognizes and binds to nerve tissue and ultimately infiltrates those nerve cells.
Okay.
So my basic understanding is it sort of blends in with the nerve protein itself. Like, oh, look, what? I'm just here. I'm supposed to be here, you know, almost in costume to get itself integrated into the cell.
Okay.
And then that part releases the other part. There's a bridge that holds them together. It's basically a chemical bond between two sulfurs.
Uh-huh.
That bond is severed,
Okay.
and the other part is free to go around and wreak havoc.
Okay.
And that other part is an enzyme.
Okay.
So you have part 1, which is a peptide that acts as a shroud to get us into the cell.
Okay.
It's the one with a plan, the man with a plan. So if you're going to commit a bank robbery, that part 1 peptide is the guy who's sneaking you in. He's acting casual. We're just going into the bank, and then he's got an accomplice somewhere that's doing something else.
Okay. Got it.
So then the accomplice, that's the enzyme. That's the other part of the botulinum toxin.
Okay.
And the enzyme, its job is to break down proteins.
Okay.
Specifically the proteins that send out neurotransmitters.
Okay.
So if those proteins get broken down, they can't send chemical signals. So then the body doesn't know what it's supposed to do. So the brain could be saying, contract that muscle, contract that muscle, contract that muscle. But the end of the line has been broken down because the protein can't release the chemical that actually causes that muscle to contract or actually tells that muscle to contract.
Okay.
So the muscle's working and the brain's working, but the communication between them that relies on that protein to release a chemical has been destroyed.
Got it. Okay.
And that's how botulinum toxin paralyzes you.
Okay.
It's all chemistry.
Yeah,
which
that's
is
crazy.
Wild to me. I mean, I know that our bodies are basically at the very tiniest level made up of atoms, you know?
Yeah.
And so it all has to be chemistry, all of it. But when I zoom in on something that I've known about for so long, and then I think, oh, this really is chemistry doing its thing, I get really excited about that.
Yeah. Yeah.
So, it's a toxin that's made up of a peptide, which is basically just a polymer in your body, and an enzyme, which is made up of a bunch of smaller, amino acids as well, with a specific function to destroy a protein whose job is also to send out a chemical signal. So it's like so much science that's happening here.
Yeah. Seriously.
So in those super small amounts, that toxin will work its way through your body. I think it usually starts with the more accessible muscles, but it eventually gets to your respiratory system. And I think that's the thing that's fatal, because if you can't breathe, you're not going to be able to live. But it might also get to your heart too. I'm not sure. Maybe the respiratory system is the first big thing to go.
Right.
It works slowly enough that you'll notice the symptoms usually first, like soon enough to where you can get some help.
Okay.
So usually you'll notice weak muscles, difficulty swallowing or talking, double vision because muscles control your eyes. So then you kind of lose the ability to control that. Something's kind of going on. Your muscles basically all just get weak. Sometimes you'll lose facial expression. And so usually all these things come together. The very rare botulism happens and people are like, oh, this is not good. And you go to the hospital because it's pretty obvious that things are going wrong.
Yeah.
If I saw that, I would actually probably think someone was having a stroke, because a stroke will sometimes affect one half of your face, but
right. Right.
But it would still immediately make me go to the hospital with whoever I saw lose facial expression.
Yeah. Yeah.
So I think because those things are happening and it's not moving so rapidly through your body, actually the fatalities weren't, it's more rare to get botulism.
Okay.
But this is a good lesson of the dose makes the poison, because if you make it an even teensy tinier amount, which is very, 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 very diluted, even below this amount,
yeah,
it can be used to help people.
Okay.
Because of interrupting this chemical signal pathway.
Okay.
So it can be used to treat wrinkles, because what it'll basically do is paralyze your face. I have a wrinkle like between my eyebrows right here. I'm doing it right now. Or like furrowing my brow.
Yeah.
Or I have one right here along the top of my forehead. So they'll inject this literal toxin. You'll poison yourself. and it will make it to where those muscles can't move. So it's not currently or constantly pushing on that wrinkle and making it more and more noticeable. And that gives the time skin to regenerate and all that stuff because it lasts for several weeks.
Okay.
So that's how Botox works. Is it literally poisons and paralyzes the place where you don't want wrinkles.
Got it. Okay.
If it's used cosmetically.
Right, right.
So you put it in there, it finds all the nerves. I'm assuming it's a very small amount, and because it's injected, it's pretty targeted and it's not getting into your bloodstream and spreading all around. I'm assuming.
Right.
I don't know for sure.
Yeah.
But that can also work if people are struggling with having eye spasms, which after my mom died and COVID had started and I was in grad school trying to survive, I had a really bad eye spasm. And my doctor told me that it should go away on its own. But if it doesn't, there are treatment options.
Yeah.
It also can treat facial spasms. So if your muscle's just spasming and you don't know why and they can't treat it, if they inject it with Botox, it will make it to where the brain cannot tell the muscle to keep spasming.
Right, right.
So the muscle will not keep spasming.
That is very interesting.
Yeah.
I used to get an eye kind of twitch, whatever you want to call it,
Mm-hmm.
when I worked for the humanitarian ministry I worked with. And I would have seasons of super high stress.
Yes, that can cause it.
Yeah. And especially if I was going to go on a trip and I had to do all kinds of planning, all that kind of stuff, my left eye would twitch, my left like lower eye right here. There'd be times in meetings where I'd have to like put my fingers on it to keep it from doing it.
Yeah.
To like at least keep my eye in the same place kind of thing.
Yep.
And eventually my boss started noticing and was like, are you okay?
No.
You know, like just like a kind of like, I need to check in on you. Seems like is your body handling this okay?
No.
You know? I was like, no, definitely not.
Yeah. My eye doctor said, just try to reduce stress. And, just saying that to anyone at the beginning of COVID, and he didn't even know anything else that was happening in my life. And I was like, yeah, I'll work on that.
Yeah.
You're like, what am I even going to do?
I'll do my best. Yeah.
This is an option, especially if it's chronic, not just like acute temporary because of stress, but if it's chronic.
Yeah.
It also can be used to treat hyperhidrosis. So that's excessive sweating. So I know someone who has this condition, and it really can be frustrating because their hands are just sweating a lot.
Yeah. Yeah.
And so you're constantly having to towel them off, and you don't want to shake hands, or, it's just not. It's not conducive.
Yeah.
Botox injections can make, I guess, the muscles that cause sweating fail to produce that reaction.
Interesting.
So that's really cool.
Yeah.
So it's also, this is really interesting, being used to treat migraines, which I don't really understand you'd have to know what was causing the migraines and target that area.
Yeah. But
they're also doing more research to re-engineer that peptide that specifically finds the nerve cells, re-engineering that to specifically find other cells.
Okay.
One is they're re-engineering it for that peptide to be able to find immune cells. And then some people have chronic inflammation because essentially their immune system thinks that they're under attack when they're not.
Yeah.
And so their immune system is always flared up, which causes them, to have these inflammatory symptoms, but it's in response to nothing.
Yeah.
Just an overactive immune system. So if you disable the signal that is being sent out that causes the reaction, boom, there goes that chronic inflammation.
Oh, yes. Okay. Interesting.
Yeah. And, if you have a muscle that's contracted and won't relax, I think that was the case for my friend. They did the Botox injection for her because it was so much pain because the muscle just would not relax. Imagine like a constant Charlie horse.
Yeah.
And then the chemical signal couldn't be sent. And so there was time for the muscle to come back and relax from that contraction.
Yeah.
Isn't that so interesting?
Yeah. It's crazy to me, too, that like something that toxic could actually have that beneficial of an application.
I know.
It's just like something can be this bad and this good.
I know. Well, actually,
based on the dose, obviously. But.
As a sort of a fun fact, it's the first biological toxin to also be approved for therapeutic uses.
Yeah, that's weird.
Yeah.
That's cool.
And the last one that I was excited about, current research is looking at how to target cells that send pain signals and use that to reduce pain in lieu of like opioids or other addictive pain relieving medicine. So you could inject this in after maybe a surgery or something similar, where you'll have long-term pain reduction until your body can recover, but you're not taking these pills and slowly building up an immunity and getting an addiction to them because it's not addictive.
Yeah. Yeah. Right.
So it's almost just like a short-term pain blocker that will, I mean, quote unquote, short-term. It would last, several weeks or whatever, but you would not have to be taking the medicine.
Yeah.
And it's not a forever numbing or paralysis just while you're healing.
Yeah. Interesting.
I know.
Wow. That's cool.
So very cool. Thanks to those researchers for figuring that out, because I think my instinct would be, this thing paralyzes people. I don't want to mess with it.
Yeah.
But it seems like they realize this thing paralyzes people. Let's figure out the pathway, the biological pathway that it takes. And now that we know, wait, I have an idea for how to optimize this.
Yeah. I bet somebody was like, kept coming up against like, if only I could very selectively paralyze this specific thing, Because like, I'm sure that depending on your field and the kind of people that you're interacting with and the problems that they're having, you realize like, oh, if only I could just interrupt this signal. If only I could get in there and stop the body from doing a thing it shouldn't be doing.
Yeah.
And then it's like, well, paralysis basically is that. But if only we could have it happen just a little bit.
Yeah.
It's like somebody was like, oh, wait a second. This stuff does that really badly. Maybe we could make it happen a lot less badly.
But how terrifying. I mean, what were those those first trials like? And I read that the Botox, even for the cosmetic procedures, is very, very, very highly regulated, but there have been cases of fatalities associated with just like an error. I'm thinking the smallest error in the dilution or injecting too much feels like it could have big impact. So that's why it's so highly regulated, obviously. But I'm just thinking the smallest little error. I mean, that is a really tiny scale to be working on.
Yeah, seriously.
So I'd love to, if there's anybody who works in the Botox industry, please tell me how you make sure that it doesn't, that it's diluted enough, because that seems so scary. But that's the basics of the chemistry behind it. So I'm going to take a break. I'll have you explain it back to me, and then I'm going to tell you about where it occurs naturally, why infants shouldn't eat honey, and some other things like that are just maybe some, not fun facts, but maybe some interesting facts about this very scary but also useful topic.
Yes. I know the honey one only because I had to care about it because I have kids. But
there might be something you don't know about it.
Yeah, I was going to say, I don't know the details. I just know no honey under 1 year old. But okay. So this is kind of hard. I feel like I get it, but I don't know if I can. Yeah, I feel like there's probably got to be something wrong here, but let's see what happens. So I think your bank idea got me thinking. And what if it's something like, you hear stories about different robberies that happen and stuff like that.
Right.
So what if we're talking about the two different parts of this, of Botox, the peptide part and the enzyme part.
Right.
Right. So the peptide part, what if it's like the situations where there's these two people that are going to rob a place, the peptide goes and gets a job at that place?
Ooh.
You know what I'm saying?
Okay, yeah.
So like very inside kind of deal.
Yes, that's a better analogy than I said.
Very above suspicion, has access, integrates into it.
Yes.
Super normal people are not that suspicious about it.
Totally.
So the peptide goes in and does that and integrates into the nerve, you said?
Yes.
And just places themselves there. And at that moment, so far has not severed any connections yet, right?
Right. So I didn't get into the chemistry of this, but the two different parts are connected by what's called a disulfide bridge.
Okay.
And then that's broken once it's integrated into the cell.
Okay, so it does kind of break a little bit.
Yeah, they break apart.
Okay.
Is my understanding.
It breaks apart.
Yes.
So it would be like the peptide's taking somebody else's job, sort of. Like, I'm here, I've integrated myself in here,
Mm-hmm.
and I am having an effect in
Yes.
this. So, yeah.
To get in. Yeah.
Yeah. So then, now that the peptide is in place,
Mm-hmm.
when the enzyme comes in,
Yes.
and the enzyme wants to actually start really affecting the connection between our brain and controlling nerves and muscles,
Yes.
then the enzyme comes in and can interrupt that completely
Yes. By breaking up the protein.
by breaking up the protein that just got in there.
Yes.
Okay. So it's like peptide gets in there,
Mm-hmm.
takes a role, integrates itself,
Yes.
but is there on purpose so that when the enzyme comes in, it can break. So it's like I become a gap in the security sort of thing. Like,
so basically, your thought is this guy comes in, gets a job, acts like he's going to work there, and instead he's hanging out so that he can smuggle the bad guy in.
correct.
Yep.
Yeah.
I think that's a great analogy.
Okay, cool.
They're sort of connected at that point, though, so that's kind of confusing. Like, is a bad guy hiding inside of your jacket?
Right. There we go.
Oh, maybe I
Little
just thought of
Rascal
something.
trench coat thing.
Oh, maybe I was thinking of like you have like a little mechanical robot. Because also the one chain is a lot larger than the other. The one that sneaks in is called the heavy chain, and the
Okay.
other one is called the light chain. So you're a regular sized human. You have a tiny robot
Got it.
that you've smuggled in. That's a really good analogy.
There we go. There we go. It took us a bit, but we got to human and robot, and
Yeah.
now we're there.
Exactly.
And then once they've both done their jobs,
Mm-hmm.
it successfully interrupts the communication between the brain and the muscle,
Mm-hmm.
the brain and the nerves.
Yep.
And then that muscle will just stay as it is and cannot be
Yes.
moved. It's fine, basically,
Mm-hmm.
especially if the dose is low and everything was according to plan. Muscle's fine. It's just it can't be contracted.
Yeah. Nobody can tell it what to do.
Yeah.
It's a perfectly functioning object. Didn't this happen with a satellite that was perfectly functioning, but we lost contact with it?
Oh, maybe so. I don't know.
It's kind of like that. It's functioning. It's doing what it was designed to do, but no one's telling it to go ahead and do it.
Right.
You know?
Right.
Yeah. So that's what happens. Another thing I thought of a good analogy of the sneaking in part, but I couldn't, connect it to the thing going and wreaking havoc.
Uh-huh.
Was in Star Wars Return of the Jedi. They pretend to be an enemy ship to get onto that moon, to the indoor moon,
Right.
so that then they can go do some other stuff. But the other stuff they're doing is really still taking down more security, so that's not really accurate.
Right. Right.
So, but it's basically it's a heist. It's a secret mission where you're pretending to be one of the group you're infiltrating, and then you release something to wreak havoc.
Right. Right.
So I think that's I love the little robot analogy. That was really exciting. Okay, good job. So that's the chemistry of how Botox works. Here are some interesting facts for you.
Okay.
So I told my husband that's why babies can't eat honey, because of botulism.
Yeah.
And he said, why don't we get botulism from it? And I thought, that's a really good question. Is it just so small amounts or what?
Mm-hmm.
No, infant botulism is something slightly different.
Okay.
So grown-ups get botulism because we eat the toxins or ingest the toxins in some way.
Okay.
That are already made, and they're in the food. The bacteria does not exist once it gets to our bodies. We kill the bacteria.
Okay.
Babies don't have the right immune system in their gut to fight off the bacteria. So if a baby ingests that bacteria, even if there's no toxins in what the baby ingests, it can set up shop in the baby's gut. And so the bacteria itself then becomes dangerous because it will produce a toxin once it's in the baby's gut. And then the baby gets the botulism.
Got it. Okay.
So grown-up botulism only comes from the toxins, or I guess if you were probably significantly immunocompromised.
Right.
But primarily comes from ingesting those toxins.
Got it.
But if you're not 1 year old yet, you're unlikely to have built up the immune system. So it's possible that the bacteria could hang out in your gut and make the toxins inside you.
Got it.
An added layer of that is infants can't communicate, and we may not notice if they're getting those symptoms.
Right.
Because they can barely control their muscles anyway.
Yeah.
So
Yeah.
it's funny to joke about how babies can't control their muscles, but it would be really scary because they might not notice. So that's why honey has the bacteria in it, but it doesn't affect adults because the toxin can't be produced in that environment.
Right. Got it. Okay, that makes sense.
And this is the other thing that I thought was really interesting. This type of bacteria, the C. botulinum, will not grow in acidic conditions.
Okay.
It primarily grows in products with low oxygen content, so not a lot of oxygen present. And then the temperature, and preservation has to be just right. And so it's pretty rare to get botulism or to get this bacteria that will give you botulism in food.
Okay.
Especially if it's acidic, because low pH, less than 4.6, that is acidic, and the bacteria can't survive in there.
Okay.
But if the toxin's already there and then you douse it in acid, the toxin can survive the acid.
Ah.
So that's interesting.
Yeah, that is interesting.
And now I'm going to read you straight from the World Health Organization website because I thought it was really very cool.
Okay.
Botulinum toxin has been found in a variety of foods, including low acid, preserved vegetables such as green beans, spinach, mushrooms, and beets.
Okay.
Fish, including canned tuna, fermented, salted, and smoked fish, and meat products such as ham and sausage. The food implicated differs between countries and reflects local eating habits and food preservation procedures. Occasionally, commercially prepared foods are involved. And then it says, though spores of this bacteria are heat resistant, the toxin produced by bacteria growing out of the spores under the low oxygen conditions can be destroyed by boiling it.
Okay.
So the bacteria can't live in acid, but the toxin can.
Okay.
The bacteria can live in heat, but the toxin can't.
Okay. Wow.
So kill the bacteria with the acid, kill the toxin with heat.
Yeah.
So, and their suggestion is internal temperature greater than 85 degrees Celsius, which is, I would say, just a little bit below boiling, probably in the high 100s Fahrenheit for 5 minutes or longer.
Okay.
It also says that ready-to-eat foods in low oxygen packaging are more frequently involved in cases of foodborne botulism because low oxygen, perfect preservation temperatures, that's how it happens.
Dang.
I know. Isn't that wild?
Yeah, that really is. That's crazy.
I thought that the most interesting thing of these facts was about the infant botulism.
Yeah.
Because once I learned how toxic it was, I didn't understand how babies could get it, but we didn't.
Yeah. Yeah. Because then it seems like, okay, that's going to get all of us, right?
Yeah. And also, why would we just be leaving that toxin in honey? That seems like a bad move.
Yeah. Seriously. The first people to try to eat honey would have discovered that we can't do that.
Right.
Like a long time ago. It would have been a no-no for a long time.
But it's because it's just the bacteria. Usually it probably has not produced the toxin.
Yeah.
And then I also think you can get infant botulism from other places, but that was really common. So they just advise against it.
Yeah. That makes sense. Dang.
So that was so cool. I was really excited when I learned about this.
Yeah, that's super interesting. I'd never knew anything about any of this stuff, and I certainly did not expect that Botox and botulism and honey would have been connected.
I know. I did not know Botox and botulism were the same thing, or that Botox was the toxin that caused botulism.
Yeah.
I also didn't know Botox worked by literally paralyzing your face. I mean, I knew kind of, but I did not think, how are they paralyzing your face? Are they injecting poison into it?
Yeah.
That's wild.
Yeah. I kind of always thought that was really just some sort of filler stuff, so that it didn't really paralyze anything. It just like kind of added a membrane of stuff between your skin and your muscles.
I do think there are fillers.
Right. Which that probably is a totally different thing, but I kind of thought it taught how all of this worked.
Yeah.
And it was just like, oh, just some stuff in there.
Yeah.
That doesn't kill you, that just plumps you up.
Yeah.
And I thought that's how all of it was. So the fact that it's really actually paralyzing you kind of blows my mind.
Yeah, and I've heard of friends getting Botox injections before, but I really thought it was like right here we're injecting some kind of gel, or we're like doing something that's going to make it, I don't know.
Yeah.
Not like a poison, but just like some kind of relief,
Right.
you know?
Yeah.
I don't know. I like a soothing gel of some kind. I don't know.
Yeah.
I don't know what I thought, but I did not think it was like, okay, we're going to get a Botox shot and now your muscle receptors will literally be failing to work. Or not the receptors, I guess. The neurotransmitters will not be released.
Yeah.
And we've paralyzed you. We've poisoned you.
Yeah.
We've medically poisoned you. It feels akin to using leeches, but I know it's not, because it's obviously effective and, whatever, but it feels on that same level of, should we be doing this? This seems dangerous.
Yeah. Totally.
So that was amazing. I loved it. I felt like I learned so much. Something else amazing happened.
Oh, is it about toxins?
No.
Okay.
Hopefully it will not be toxic at all.
Okay.
Because I started my new job this week.
Oh.
Yay!
Who knows if that'll translate? Maybe we'll just cut it out. Who knows?
No, I liked that. So last time we talked about my new job, I actually is a little outdated information. I had a job lined up where I was going to be working at the University of Ottawa remotely. The advisor was incredible. She's so nice. And I was really excited. But just due to immigration things and tax documents, it couldn't work where I could work remotely and live here where my husband's job is and then work at that school.
Right.
I had to be in Canada, but I couldn't be in Canada. That was a problem.
Yeah.
So I had to say no to that. And I was really sad, but another really good offer came along and I started today, actually.
Nice.
This is my very first day of work. And so I'm doing research with Dr. Jordan Hirschman at the University of Auburn in Alabama, but I'm mostly going to be here, not in Alabama.
Right.
I will be visiting, of course, but I'm really excited. He does cool research looking at graduate student education in chemistry. And it's a little bit different than stuff I've done. And he has a lot of good skills that I think I could learn. And I think it's just going to be a really great opportunity for me to do a different type of research. So
dude,
that's what I'm shifting to.
That is so cool. Congratulations.
Thanks. I'm so excited.
Obviously, I remember you being in the limbo zone for a while, and that was not fun. And so I'm so glad that it's actually all official and you actually have a job and you're not having to wonder what's going to happen.
No, I signed a letter and I started working. It's official. The only thing I don't have is like my actual paperwork signed yet, but that should happen by tomorrow. So very exciting. I'm so happy. And I think he actually sometimes listens to this podcast while he runs around. So if you're listening, Dr. Hirschman, what's up? I can't wait to work in your lab. I mean, I guess I am already. So.
yeah. Can't wait to continue working in your lab.
Can't wait to wake up tomorrow and do day 2. Really, when I woke up this morning, it felt like the first day of school. Like
that's so cool. I love that feeling.
I was so excited.
Yeah, that's awesome.
Then I had to do a bunch of like paperwork, figuring out where I needed to go. That was less fun. But the beginning part, and I got to go to group meeting. Those parts were fun.
Nice. Well, I definitely can't compete with that. So I'm not really going to try to.
You don't have to try.
Yeah.
We can just admit, it's like pretty exciting.
Yeah, it's exciting. And we don't even try to compete whenever we do this usually anyway.
Yeah, that's true.
But the only thing I really think of that is cool to share is really for both of us.
Oh, yeah.
So you guys, we have been on Ko-Fi for a long time where that's been where people have been able to support us, go give a one-time or a recurring kind of donation support tip jar sort of deal.
Right.
To be able to help make the show possible. You guys have heard us talk about this. The show costs money to produce and the people who give allow that to happen.
Yeah.
So basically,
they've had a direct hand in giving us transcriptions, making sure that we have mics that are working. I was able to go share about the podcast at a conference recently because of some of those donations, things that I would not have been able to do or we would not be able to do without that. So and it also pays for our hosting fees to put the podcast out. So literally we could not do the show without money.
Yeah, 100%. And we have thought about this a lot and been working on this for a little while and thinking about it and asking other people. And we've decided to move from Ko-Fi over to Patreon. it's a platform that I would guess about 85% of you are pretty familiar with and have heard of.
Yes, definitely.
And that's part of the reason it's just more known and it's more common and people are familiar with it. It also lets us do cool things like it's a little bit easier for us to give you guys perks and do cool stuff with you to keep you involved and in the loop on stuff if you're someone who supports our show.
Yep.
So we decided, why not?
Let's do it.
It seems like you guys, I mean, in general, it's the same need. It's fulfilling for us to be able to continue doing the show and cover the cost of it. But it makes it, I think, cooler and more fun for you guys.
Right.
And so that's our goal there. That's what really sold us on switching over. So you can tap the link in our show notes or go to patreon.com/chemforyourlife and check it out. Join. You've got some options on what perks you want and all that kind of stuff.
And the options are based on the different intermolecular forces, which I'm really excited by. So it's a little chemistry lesson in and of itself.
It's very nerdy and very cool. The kind of thing that hopefully all you guys are down with if you've liked the show. So
I'm so excited.
So go check it out and join us if you can. And we will see you over there. And thanks for helping keep our show going. And hopefully this will be a more exciting way to do that for you guys.
Yeah, so we're excited to see you over on Patreon. Thank you so much already for those of you who have given one time or monthly on Ko-Fi. We really appreciate it. We would not have been able to do this show without you. And thank you, Jam, so much for letting me teach you all about Botox. I know you didn't care about it at the beginning, but hopefully you cared about it at the end.
Yes, I do. I mean, I think I cared about it, maybe not the way that everybody would, but now I know more about how it works, which is cool. So thanks for teaching me and us about that. And if you have an idea or question like Sam had when he asked about Botox a while ago, you can reach out to us on Gmail, Twitter, Instagram, or Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the cost of making it, go to patreon.com/Chem for Your Life. That's Chem, F-O-R, Your Life, to support the show. If you're not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jerem Robinson. And we'd like to give a special thanks to A. Collini, who reviewed this episode.